Let's say you are asked to integrate this kind of question, you are asked to evaluate it. Now, it's very simple. You just need to go with substitution method. So using substitution method, this is just it. You can just let u equals to tan x, right? And whenever you differentiate your du, you are going to have du to be equals to what? That's sec square x dx, right? Then go ahead and make your dx the subject of the formula. Making your dx the subject of the formula, you're going to have it to be that way. Dx equals to du divided by sec square x. That's very simple. So let's go ahead and put all this value into what? Our integral. So that we are going to have integral, you're having from 0 to pi over 4. Then you're having tan cube x. You can remember this is actually tan cube x, right? And u equals to tan x. That means my u cube will be equals to what? That's tan cube x, right? I will be having u raised to the power of 3, then sec square x multiply what? Then here you'll be having du divided by what? Sec square x. That's very good. So in this case, I'm going to have my sec square x. This will cancel this, right? Show that I'm going to have that's integral from 0 to pi over 4, right? U raised to the power of 3, then du. So let's go ahead and integrate it. Just integrate this. So integrating this aspect, I'm going to have that's I'll be having integral. Let me just say integral, all right, of 0 to pi over 4, right? Then u raised to the power 3 du will becomes that's u raised to the power of 4, 3 raised plus 1 divided by 3 plus 1 divided by what? 4. Then from our 0 to what? Pi over 4, right? So this will gradually becomes, this will become that's or we having it to be that's no, you can just recall actually. If you recall, you can recall that your u is what? That's tan x. Shake it down. So here you are going to have tan raised to the power of 4x divided by 4 from what? From 0 to what? Pi over 4. So in this case, you'll be having this as that's substituting the upper limit and also the lower limit. Putting it here, you're going to have tan raised to the power of 4 into brackets pi over 4 divided by what? That's 4. Then minus tan raised to the power of 4 into bracket 0 divided by what? That's 4. So that's just it. But in this case, you just need to go ahead and simplify. In order to simplify this, my pi as far as trigonometry is concerned, pi is taken to be what? That's 180. And the 180 divided by 4, that should give us something like that's I think 45. Right? So that should be 45. Let me just verify it. 180 divided by 4. I'm right. Exactly 45. So here in this case, I'm going to have my what? My tan raised to power 4 of what? Of 45 divided by what? Divided by 4, right? Minus that's I think everything here is actually 0. And 0 is actually that's 0. So we are going to have minus 0. So our final answer is actually that's tan raised to the power of 4 of 45 divided by 4. So if you like, you can just go ahead and use your trigonometry method to just simplify this and get your final answer. Or if you like, you can just go ahead and press it on calculator to get your final answer. So in this case, our final answer is going to be that's tan. That's my tan, right? Tan raised to the power of 4 and 45. That's raised to the power of what? Raised to the power of 4 divided by 4. I think our final answer is 1 over 4. So that's just the answer, but that's the answer, 1 over 4. So another thing that we can have is actually, I feel like we should just simplify. Simplifying this should give us something like, let's try to convert it in pi forms. I think this is actually 45 divided by 180, and that is actually 45 divided by 180. 45 is actually 1, and this is actually 4. So my 180 is what? Is 4, is pi. You can recall pi equals to what? 180 as far as trigonometry is concerned. So it will be better if we just leave that. That's 45 divided by what? Pi. That's the answer. Or you just go ahead and do it, because 45 here goes in this way, that's 1, and 45 in 180, that's actually 4. So you have it to be what? 1 over 4. So you can leave your answer like this, or you just go ahead and say you have 45 divided by what? Pi. So that's just it. This question is actually different. So looking at this question, I don't think we can use our substitution method, but the best method that we can use is actually the partial fraction. So look at the question. I'm having x raised power 4 minus 1, right? So first thing, what can I do here? My 1 raised power 4 is the same thing as writing 1. Abi? Yeah, it's the same thing. So I can just say let me just do it like this. X, let me equals to 0. Let me just say this one is equal to 0, right? Show that I'm going to have my x to be equal to what? X raised power 4 to be equal to that, I think, plus 1. Right? So here I can have s squared multiplied with s squared, right? Equals to 1. Then here I can have it to be s square, shake it down, then multiply what? X, shake it down. I'm finding square root, or let me just say I find square root of both sides. I've squared the root of both sides, so I'm going to have my s square to be equal to 1. Actually, breaking it down, I'm going to have my s square to be equal to 1. So I can just have to x equals to what? Plus and minus root of what? Root of 1. See what I sign down? That means I'm having my s to be equal to what? That's plus or minus 1. It is very simple. So I just try to break this one down because, looking at this, I'm going to have this square, you cancel this cancel this out, then s multiplied by x is what? S square. She get down. So this is my s square here equals to what? Then squaring it, I'm having root of 1. The other side down. So that's just it. So without following this aspect, let's just go ahead and use simple algebra. Here I can just say this is s is power 4 minus 1, right? I can change it to s square minus 1 and also what? S square plus 1. I can actually write this because by the time I expand it, I'm going to have this my answer back. Let's just go ahead and expand it. So expanding this, I'm going to have s is power 4. This multiplied this, that's having minus s squared plus what? Plus s squared, right? Minus 1. So this will cancel this out. I'm going to have s power 4 minus 1. So it's very simple. So instead of me to just go ahead and use this like this, I can just rewrite it as what? As writing it as that's integral from 2 to 3. Right? I'm having my 2x divided by what? That should be s square minus 1 into brackets s square plus 1 dx. Right? So in this case now, if you look at what I just did here, I said s square equals to 1, then s equals to plus or minus root of 1. It's still the same thing as this, because if I have something like this, I can just say this is, that's s square minus 1 equals to 0. Then s square equals to what? 1. I'm going to have s to be equals to what? Plus or minus what? Root of what? Of 1. Then s equals to what? Plus or minus what? Plus or minus 1. That means my s minus 1 and also x plus 1 can work, because here this is x equals to 1 or s equals to what? Plus 1. Minus 1 rather. She get down. So by the time I bring this side to this side, I'm going to have x minus 1 equals to 0. And here, or x plus 1 equals to what? 0. So that I can just have the factor to be x minus 1 into bracket x plus 1. So by the time I expand this, I'm going to have my x square minus 1 back. So I can just rewrite this, everything here as what? As integral 2 to 3, right? Then I'm going to have 2x divided by what? Divided by, that's x minus 1, right? X plus 1 into bracket s square plus 1 dx. That's just it. So now let's go ahead and integrate. So going ahead and evaluate this integral calculus. Actually, the difference between the indefinite and also the definite integral is just what? The upper and also lower limit. That's just it. So the limit is just what differentiates the indefinite and also the definite integral from each other. So now let's go ahead and resolve this into partial fraction. I'm going to have 2x divided by what? Divided by x minus 1, right? Into bracket x plus 1, right? Into bracket s square plus 1. Now let's integrate it together. Here, let's resolve into partial fraction together. Here I can just have it to be a divided by what? That's x minus 1, right? Then plus what? Plus b divided by what? That's x plus 1, right? Then plus, here I'm having quadratic function here, that is polynomial of degree 2. Then this is going to be cx plus what? Plus d divided by what? S square plus 1. So that's just it. Now let's just go ahead and resolve it to partial fraction. So resolving this one into partial fraction, I'm going to have x minus 1, right? Into bracket x plus 1 into bracket s square plus 1, right? So which is equals to, that's 2x. Let's just assume that this has cancelled this out. Just that's just a waste of time, but let's just go ahead and just write put it there. I'm going to have x minus 1 into bracket x plus 1, right? Into bracket s square plus 1. That's just it. Then I'm going to have this one to be, this to cancel this out. I'm going to have this one left. I'll be what? If a into bracket x plus 1, right? Into bracket, that's s squared plus 1. That's all. Plus, this to cancel this out, Abby. This, we cancel this out. I'm left with these two. So I'm going to have my b into bracket s squared plus 1, which is this, into bracket again. I'll have this x minus 1, right? Then plus cx plus d. My cs plus d, this is going to cancel this. I'm left with what? X minus 1, right, into bracket x plus 1. That's just it. So the funniest thing is that I can go ahead and open the possible bracket, but opening the bracket is going to be a long process. So that's going to just delay us. But let's just go ahead and just use trial and error. It's just trial and error method. Now look at this. I'm going to have, looking at this, I have my x plus 1 here, which is a linear equation. I have my quadratic function here. This is actually a polynomial. Let me just use polynomial of degree 2, degree 1. No, degree 1 is a linear equation. So here I'm going to just take my x plus 1. Then my x plus 1 equals what? 0. Therefore, if x plus 1 equals 0, that means my x equals what? Minus 1. Making your x the subject, you are going to have x to be equals to what? Minus 1. Then I'm going to put everything here into this equation, into everything that is here. So, but before that, let me just write them out. I'm going to have my what? My 2x, right? Then equal, this you cancel this out. Then I'm going to have equal a into bracket x plus 1, right? Into bracket again, s squared plus 1, right? Then plus b into brackets s squared plus 1, right? Then I'm having it to be x minus 1. Then what again? I'm having plus what? Cx plus d, right? Then into brackets x minus 1 and open another bracket x plus 1, right? So this is just it. And I wish you can just open the bracket. Should we just go ahead and open the bracket? Let's open the bracket and just try to wait for it like that. We're going to have 2x equals to, this will give us a into brackets. This time this will give me x raised power 3, right? This multiplied by this, that's what? Plus x. This multiplied by this, dot, plus s squared, then plus 1. That's just everything I have here, right? So here let's go ahead, plus b into brackets. This time this will give me x raised power of 3. Then this time this will give me minus s squared. Then I'm going to have plus x, then minus 1. Let's close it. Then plus cx plus d into brackets. This time this is going to give me, that's s. I think everything else should just go as s squared minus 1, because x times s is s squared, then minus x plus x, then minus 1. So minus x and plus x will cancel each other. That's all it. So let me just call this one my goodness of a. That's equation a. So look at this. S times this is giving this time this is giving this time this is giving this, right? This time this is giving right. So now let's just go ahead and just look at this. Looking at this, I have a linear equation here. I have a linear equation here. I have a linear equation here, which is there are two here actually. So I'm going to set this one to be equal to 0. So let x plus 1 equals to 0, just exactly as what I did here. So then I'm going to have my x to be equal to what? Minus 1. Then I'm going to put my minus 1 inside everything here. Now the funniest thing is that, whenever I just look at my x very well, putting x here, substitute your x as minus 1 here, putting it there, you're going to have it to be what? Minus 2 equals to. Now calm down and listen carefully. You're going to have x equals to minus 1, right? If you put minus 1 here, minus 1 plus 1, that's actually what? 0. Then a multiplied by 0 is what? 0. 0 multiplied by this is what? Is 0. That means my a is going to what? To cancel out. Right? So my a has already cancelled out from this case. So equals to what of my b? My b minus 1. If I put minus 1 here, minus 1 square is actually what? Minus 1 square is 1. That's 1 plus 1. I'm having 2 here, right? Then this one is what? Minus 1 minus 1, which is what? Minus 2. Then minus 2 multiplied by 2 is what? That's minus 4b. So I'll have it what? Minus 4b here. Right? So I'm having minus 4b here. What of this case? Minus 1 plus 1, that's actually 0. So this time this is what? 0. 0 times everything here is also 0. That's just it. So now let's just look at this very well. I think let me just, minus 1 all squared. That's actually what? 1. 1 plus 1 will give me what? 2. She get down, which is this 2. Then minus 1 is actually what? Minus 2. Minus 2 times this is what? Is 4. So in this case now, this you cancel this out, right? Sure that I'm going to have my b to be equals to, that's 2 by 4. 2 divided by 4, which is equals to what? That's 1 over what? Over 2. So our b in this case is what? 1 over 2. So now let's just look at another case now. Looking at another case now, look, I'm having x minus 1 here also. So I can just say, let me just say, let my x minus 1 equals to 0. So therefore, my s equals to what? Plus 1. Then look at it very well. If I put my plus 1 here, nothing is going to happen. Because plus 1, that's actually what? Plus 2. Plus 2, right? So then putting my plus 1, I'm going to have 1 plus 1, which is what? Which is actually what? That's 2 again, right? So it's very simple. Then looking at this, if I put my plus 1 here, everything here is what? Is 0. It shows that my b cancel out. Then putting my plus 1 here, everything here is what? 0. See, also, everything here will cancel out. Then I'm left with what? With, that was actually my 2 into bracket 1, which is what? 2. Everything here equals to what? I'm having 4a. Yeah, exactly. Because this is 1 plus 1. 1 square is 1 plus 1. That's actually 2. Then 1 plus 1 is what? 2. 2 times 2 is what? 4. I'm having 4a also. Then divide both sides what? 4. Divide both sides 4. This cancels this. I'm going to have your a to be equal to what? 1 over what? Over 2. Our a is 1 over 2 and our b is 1 over 2. What's going on? All the best. So now let's just look at this very well. Now, I don't think I have any other equation that I can just use to get my C and D, but I can just go ahead and open these brackets very well. Then I will try to compare the coefficients because that's the only thing I can do here. So now, looking at this, I'm going to have it to be what? To be 2x equals to what? Look at this. I'm going to have this to be what? Ax raised to the power of 3, right? Plus what? Plus a, right? Then plus what? Plus as square plus a, exactly. Then that's for my a side. I'm going to have plus what? Plus b s raised to the power of 3, then minus b s square, right? Then plus b x minus 1 minus 1b, which is b, exactly. So now let's confirm it. This time this will give us this, right? This, we are right, exactly. Can you see this now? So here a times x is what? Ax. Can you see this now? So it's good for to confirm. Then this time this will give me what? As square. Then this time this will give me a. Then I'm going to have my b times s cube, bs cube. Then b times s square minus bs square, b times x. I'm having to be b times x. Then b times minus 1 is going to give me to this. So it's very simple. So the next thing is that let's just go ahead and just expand this. Yeah, let's go ahead and expand this. No, I'll try to rewrite this one this way because that's the best thing to do. So expanding this on its own, I'm going to have this time this will give me what? That's c x raised to the power of what? Of 3, right? Then this time this will give me what? Minus cx. Then I think that's all. This time this will give me what? Plus ds raised to the power 2. Then this multiply this will give me what? Minus d. So I think that's just it. That's it. So now all I just need to do is just to compare the coefficients. But I won't bother myself in this case. I will just go for my C and D because that's just what we need to get in this case. So look at this now. The power of x raised to the power 3 at the left hand side is 0. The power of x raised to the power 3 at the left hand side is what? 0. Power of x raised to the power 2 at the what? At the left hand side is also was 0, right? But I'm having x raised to the power of 1. So I can just go ahead and say, okay, my C, I'll compare those that have what? X raised to the power 3 first. I'm going to have it to what? My A is having x raised to the power 3. That's what? A x raised to the power 3. Then I'm having what? That's plus what? Plus C x raised to the power 3, right? Am I having my B? Yeah, exactly. Plus what? B x raised to the power 3. What of D? I'm not having. Equals to 0. Can you see this down? Show that I can just divide all 3 by what? By s raised to the power 3. Divide, let me just say all true by what? By s raised to the power 3. Then I'm going to have a plus c plus b equals to what? 0. So that's my first equation, right? Then let's do the same thing for d. D is having s raised to s square, right? So the power of s square in this side is actually what? 0. So that means I can just compare those that have s square. I'm going to have my as square, right? Then minus, I'm having my bs squared, right? So then again I'm having what? Plus ds squared equals what? 0. That's very good. So in this case now, doing the same thing, I'm going to divide all 2 by what? By s squared. I'm going to have a minus b, right? Then plus d equals to what? 0. You get right hand. So therefore my d equals to what? That's bring everything in this guy. I'm going to have minus in the bracket a minus b. So that I'm going to have my d to be equals to what? Minus a plus what? Plus b. That's another equation 2. So these two equations are what I'm going to be using now. So looking at this, my a is what? My a is 1 over 2. That means I'm having 1 over 2 plus c is what? Unknown, then plus my b, which is what? That's 1 over 2 equals to 0. 1 over 2 plus 1 over 2, I think that's 1. So my c in this case is what? Is 1. Because 0.5 plus 0.5 is actually 1. So my c in this case is 1. Is it 1? Not just ordinary 1. It is minus 1. Because by the time I collect like times here, that's minus 1. So then let's just move to my d. My d equals to what? That's minus a plus b. Then I'm having my d to be equals to what? Minus 1 over 2 plus 1 over 2, which is equals to what? 0. So that's just it. So now let's just go ahead and let's come back to this equation. What is it? This is the equation, right? Show that here, my a in this case is actually what? That's 1 over 2. My b equals to what? 1 over 2, right? Then my c equals to what? Minus 1. And my d is equals to what? That's 0, right? So this equation will actually become 1 over 2 divided by what? That's x minus 1, right? Then plus my b is actually 1 over 2 divided by what? X plus 1. Can you see this now? Plus my c is minus, then I'll be having minus x. No, my c is minus 1, that's minus x plus d, which is 0, divided by what? S squared plus 1. Wow, everything is 0. It's actually making sense. So now let's just go ahead and just introduce our integral sign. So introducing our integral sign, I'm going to have integral. I'm not going to put limit in this case. I'm going to have here, I can just bring down my 2. I'm going to have 1 over 2 into brackets. Then I'm having x minus 1, right? Then I'm having plus, again, 1 over 2. I'm bringing down my 2. Then I'm going to have x plus 1. Then, again, I'm going to have minus x divided by what? That's my s squared plus 1. Then I'm having dx. It's very simple, right? All the best. So now let's just go ahead and integrate this. I'm going to separate them one by one, and then I will integrate. Separating it, I'm going to have it to be, I'll have this one to be integral of 1 over 2 into bracket x minus 1 dx. Let's deal with this first, right? So dealing with it, I'm going to have 1 over 2 integral of 1 over what? Over x minus 1 dx, right? So, and you can recall, if I should differentiate everything here and I'm having the same thing as just this, then that's lane, right? So here, okay, let me just try to solve this one for you. Because I'm going to say let what? U equals what? X minus 1. Then your du equals what? Dx. Your du equals to what? Dx in this case. So come back here, I'm going to have 1 over 2 integral of 1 over what? Over u. My dx is what? Du. And you can recall, whenever you have integral of 1 over x, that's dx, that's what? Ln x plus c, right? So here I'm going to have it to be, that's 1 over 2 ln u, or you say log u. Then you can recall, your u equals to what? X minus 1, right? So I'm going to have it to be, that's 1 over 2 natural log of x minus 1. Then am I going to add plus c? No, don't let me add plus c, because I'm actually integrating with limits. You understand that? So I'm going to evaluate it later. So let me just call this one my first one, which is equation 1. Now let's just go ahead. No, the same method is also applied to this. I'm going to have this to be what? 1 over 2 inertial log of what? Of x plus 1. Right? So let me call this my what? My second one. But the last one, if you look at the last one very well, I'm going to have integral of not this negative integral of x divided by what? That's s squared plus 1 dx. So I'm going to use my substitution method here, because I can't just go ahead and say this one is just inertial log of. No, it's not inertial log. I'll use my substitution method. So u equals to what? S squared plus 1, right? So du equals to what? 2x dx, right? Then my dx equals to what? That's du divided by what? 2x. That's it. Then go ahead and put it back. We're going to have minus integral of x divided by what? Divided by, that's u. Multiply by what? My dx is what? Du over what? 2x. This cancel this out. Then I'm going to factorize minus 1 over 2 integral of 1 over u du, right? Which is also minus 1 over 2 inertial log of what? Of u. But we can look at this now. My u is what? My u is something, right? So I'm going to record that my u is what? X squared plus 1. I'm going to have minus 1 over 2 inertial log of what? Of u, which is what? Inertial log of what? Of s squared plus 1, right? This is my what? My 3. So combining the integral of everything together, I'm going to have it to what? To be 1 over 2 inertial log of what? Of x minus 1, right? Then plus 1 over 2 inertial log of what? Of x plus 1, then minus 1 over 2 inertial log of what? Of s squared plus 1 plus c. I'm adding plus c. Let's say I'm asked to integrate. Let's say what I'm asked to integrate is actually what? Indefinite integration, right? That means it doesn't have limit, right? So in this case now, my c is going to represent the arbitrary constant. That's the constant for f of x. So now let's just go ahead and factorize this or simplify this. I'm going to factorize that. I can actually factorize my 1 over 2 out. 1 over 2, then I'm going to have into brackets, that's ln what? Ln x minus 1, right? Then plus what? Plus, that's ln what? Ln x plus 1, then minus what? That's s squared plus 1, right? So plus c, I can still go ahead out and simplify it, right? But don't let us waste our time. Then you can just go ahead out and leave the answer like this. If it is you are integrating without limit, but let's say we are integrating with limit. Now in the case that we have integral of what? Of 2 to 3, right? So I'm going to have integral of 2 to 3 of what? Of 2x divided by what? That's x squared, x raised power 4 minus 1. The x is the same thing as what? As that's 1 over 2 into brackets ln, that's x minus 1, right? Then plus what? Plus inertial log of what? Of x plus 1, right? Minus inertial log of what? Of s squared plus 1. Then I will have it from what? From 2 to what? To 3. That means I'm integrating from what? From 2 to 3. So let me just go ahead and what? And integrate this and finalize the answer. So here I'm going to have it to be, since I'm integrating with limits, I'm going to have my 3 first. I'm going to have 1 over 2, then inertial log of what? Of 3 minus 1, right? Then plus inertial log of what? Of 3 plus 1, then minus inertial log of what? Of 3 squared plus 1. Exactly. So here I'm going to have 1 over 2 into brackets inertial log of what? Of 2 plus inertial log of what? Of 4, then minus inertial log of what? 3 squared is 9 plus 1, that's 10, right? So this is my first one. Let me just start it, right? So when my x, let me just say when x equals to 3, then when s equals to what? 2. Now I'm going to put it there. I'm going to have 1 over 2 into brackets inertial log of what? Of 2 minus 1, right? Then plus inertial log of what? Of 2 plus 1. Then that's minus inertial log of what? Of 2 squared plus 1, right? So in this case, this turns to 1 over 2 into brackets inertial log of what? Of 1 plus inertial log of what? Of, that's 3 plus 1 is what? 3 plus 1 is, that's 3. 2 plus 1 is 3. Then minus inertial log of what? 2 square plus 1, that's 5, right? So that's just my what? My second. Then I'm going to have it to be like this. Then 1 over 2 into bracket inertial log of what? Of 2 plus inertial log of what? Of 4 minus inertial log of what? Of 10. Then into brackets minus again. This is my upper limit and this is my what? Lower limit. Right? So when s is 3 is my upper limit and when s is 2 is what? Is my lower limit. Then I'm going to have it to 1 over 2 into bracket. Then this is minus 1 over 2 into brackets inertial log of what? Of 1 plus inertial log of what? Of 3 minus inertial log of what? Of 5. Can you see this down? So go ahead and what? And solve this. Then make sure you drop your answer in the comment box below. So let's see the question I'm having here with. The question says that integral of 0 to pi sin 7x cos 2x dx. Oh, this is another integral problem, but it's very simple, right? So let's go ahead and, if you know you can solve this, just go ahead and pause the video, then try it on your own, and make sure you drop your answer in the comment box below, right? So now look at this. If I'm giving this kind of question, how am I going to solve it? It's very simple. just need to apply some trigonometry identity. And for those of you that you are not familiar with trigonometry identities, kindly pause this video right now and go back to my previous video. Make sure you watch the how I prove all the formula, all the identities on trigonometry. Now look at this video, look at this question rather. I'm giving sine 7x cos 2x dx. No, in this case I can just say let my 7x equals to a, then similarly my 2x equals to what? B, right? That's just it. So looking at this, no, everything is going to be what? That's sine what? Sine A cos what? Cos B. And you can recall from your trigonometry identity that whenever you are having sine A cos A, sine A cos A is actually the same thing as writing that's or you can just say sine A plus B. Let me just say A plus B, right? Then plus you have sine what? Sine A minus B. Then this should be the what? Let me just say divided by 2 here. You have it into what? Divided by 2. Or you can just factorize 1 over 2. You can just say you have it to be 1 over 2 into bracket sine A plus B, right? Then plus sine A minus B. That's very simple. So it's just an identity. So in this case now, I will just go ahead and make use of this. Show that what my integral is going to become 0 to pi. Then sine A, I'm going to have it to what? That's 1. Let me just factorize 1 over 2 out of 1 over 2. Then I'm having this to what? Sine. What's my A? My A is 7x. 7x then plus B, which is 2x, right? Then plus, I'm having it to what? Sine. That's, the next one is actually 7x minus 2x dx. So I'm going to simplify first because before I just separate, I'm going to have integral of 0 to pi, right? So I'm going to have sine 7 plus 2 is actually 9x, then plus what? Sine this minus this is actually 7x minus 2x should give me 5x dx, right? So let's go ahead and integrate it. Let's just bound this one for now, right? You understand? I'm having integral of what? Of sine 9x, then plus integral. Let me have my dx here. I'm separating now sine 5x dx, right? So I can just use my substitution method. Using my substitution method, I can just say let u equals to what? 9x. Then du equals to what? 9 dx. Then our dx will be equals to what? Du over 9. Sure that you are going to have integral of sine u du. And whenever you integrate sine u, you should have negative cos what? Negative cos u, right? Then don't forget that you're having over 9 here, right? So now let's go ahead. I'm going to have 1 over 9 integral of sine u du. Then what of this case? I will have it to be what? If you follow the same thing, that's 9x is this is what? 5x. So here it should be what? 5. So I'm going to have du over what? Over 5. So that I'm going to have this also to be plus. That's 1 over 5 integral, right? Of what? Of sine. Let me just say p in this case. Let p equals to 5x, right? Then dp equals to what? That's 5 dx. So in this case, your dx equals to dp over 5, right? So yeah, just put it there. I'm going to have it to be that's the integral of sine p. Then dx is what? dp over 5. Can you see this now? So factorize the 1 over 5 out. You're going to have 1 over 5 integral of what? Of sine p dp. So now let's just integrate this. You're going to have 1 over 9 minus what? Minus cos u. Then here you're having plus 1 over 5, right? That's, in this case, integrate this one, that is actually minus cos what? Cos p. Check it down. Then plus c. No, I said we should neglect this first. So let's just go ahead and what? And you are going to have minus 1 over 9, right? Cos your u is something. What's your u? Cos 9x. Then plus 1 over 5 minus what? Cos 5x plus c. Exactly. So in this case now, bring your minus out. If I choose to bring out minus, I'm going to have minus into brackets. But let me just go ahead and put it there. That's cos 9x. Then here we have minus 1 over 5. Then cos 5x. In this case now, let's just say we have our upper limit to be what? 0 and our lower limit to be 0 and our upper limit to what? To be pi. So if you want to go ahead and If you are not integrating with respect to this limit, or you are not giving limits, this is actually the final answer. You are not giving limits. But let's say you are giving limits. That's 0 to what, to pi, right? So here you are going to have it to be that's minus 1 over 9, then cos 9 into bracket what, pi, right? So here we are going to have minus 1 over 5, then cos 5 into bracket, your x is what, is pi again here, then minus, no, this is different. Then you are going to have it when it is 0, minus 1 over 9, that's cos what, cos 9 into bracket 0, she get down. So then minus 1 over 5, then you have it with cos 5 into bracket what, 0. So now you can feel free to go ahead and solve this, and make sure you drop your answer in the comment box below. You must drop your answer, you understand? I'll be there to reply you if you are right or you are wrong. So go ahead and press your calculator. Cos 9, given that your pi equals to 180 as far as your angle is concerned. But if you are not dealing with angle, your pi is what, is 3.142, which is what, 22 over what, over 7. So but in this case you are using what, 180. Just go ahead and substitute your 180 here, put a 180 here, yeah, and that's all, right? So we'll be good. So make sure you drop your answer in the comment box below. So that's just easy way to what, to integrate this. Make sure you drop your answer. Thanks for watching.